I am Kane Orvad, and this is my Assignment 3 submission. So the prompt is, how can I use this starting point of a tetrahedron to demonstrate both my knowledge of complexity as well as my creativity as an engineer? So I've analysed three critical components of complexity to really demonstrate how they link together. So those concepts are the Meadows model and emergence, as well as cybernetics of feedback. So Meadows and emergence link together because the emergent behavior which is created by a system is fully dependent on the structure which is applied to each component. So there's a really good example of this in nature, which is the shape-shifting of a flock of starlings or birds called murmuration. So each bird in the flock acts with specific behavior in relation to the birds next to it, so they don't collide. But also each bird is fully unaware of what the murmuration looks like from an outside perspective. So here, the Meadows model that's applied to each individual bird is really how the bird processes that information to not collide. Now that's really the structure of solving the problem. So it's still actually under debate among scientists as to how they go about doing that. But changing how each individual bird interprets their surroundings or how they solve the problem is clearly going to change the nature of the emergent behavior of the flock as a whole. Now, cybernetics and feedback also link into this theory of emergence in much the same way. So the way the inputs to a system are structured are going to determine the outputs of that system, which are therefore going to influence the emergent behavior of a structure. So whether those birds are undergoing positive feedback loops or negative feedback loops, or feed forward or feedback, is going to influence that information processing and that sort of Meadows structure as I was just talking about, which is therefore going to influence that emergent behavior. Now, these linking concepts of complexity can be applied to this tetrahedron shape. So the challenge is really to make something complex from something simple, which is normally the opposite of what we try to do as engineers. So any physical structure or shape that I make is going to be complicated at best because it's going to be fully defined by me. So what structure can I use to turn this simple object into something complicated? So I decided to change how I look at this shape and what it represents. So instead of seeing a tetrahedron, to me, it represents a methane molecule. So methane is complex depending on what scale you look at. So if you zoom into each covalent bond, you can either know where the electron is or how fast it's traveling, but not both, which to me is really the perfect example of complexity. So you can actually zoom out as well. So on a larger scale or system, each molecule in a given amount of methane gas is behaving according to the relatively simple models of physics, but modeling the behavior of the gas as a whole is complex. So the structure in which the problem is solved, i.e. the Meadows model through the laws of physics, clearly has an impact on the emergent behavior in those examples that I've just given. So in some parallel universe where the laws of physics are going to be different, the emergent behavior which is exhibited by this molecule would be completely different. So somehow this simple object has become an extremely complex issue on many different levels, just depending on the structure that you apply to it, as well as your perspective.